Advanced Algebra 2, Concept 12, Solving Nonlinear Systems. So we're going to solve by graphing, substitution, and elimination. Alright, so previously you've solved systems of linear equations by those three methods, graphing, substitution, and elimination. You can also use these methods to solve a system of nonlinear equations. So in a system of nonlinear equations, at least one of the equations is nonlinear. For an example, maybe a quadratic. If you look at the system below, the nonlinear system has a quadratic equation and a linear equation. So equation 1 is nonlinear, it's quadratic, y equals x squared plus 2x minus 4, and y equals 2x plus 5. So when the graphs of the equations in a system are aligned in a parabola, like the three graphs in the first row of this table below, the graphs can intersect in 0, 1, or 2 points. So the system can have 0, 1, or 2 solutions. And then if you look at the bottom row, when the graphs of equations in a system are a parabola that opens up and a parabola that opens down, the graphs can intersect in 0, 1, or 2 points. So the systems can have that many solutions. So we have systems that have one solution, systems that have, no solutions, systems that have one solution, and systems that have two solutions. Let's look at example 1 and solve this nonlinear system by graphing. So we'll graph both of these equations and see where they intersect. So the first one is a parabola in standard form. So let's write it in the first table. And let's find the vertex. You know that's where we need to start to graph. So we take the opposite of b divided by 2a, which gives us positive 1. Then we plug positive 1 into the equation to get our y value. So our vertex is at the point 1, negative 2. Now place x values 2 steps below and above positive 1. And then plugging those in, we get y values of 2 and negative 1. Now let's look at our second equation, which is a line. Y equals negative 2x minus 1. And I'm just going to point out that our y-intercept, the b value, is negative 1, and our slope is negative 2. And we'll think of that as negative 2 over 1. So draw your axes in your graph space and then label your scale. And let's start by plotting the parabola. So let's plot these points and then draw a smooth U-shaped curve. Now let's plot the line. So let's put our first point at our b value, so negative 1, and then we'll use the slope to plot the other points. So we'll go down 2 and over 1, and up 2 and over 1 to the left. We can see by our graph and also in the table that our point of intersection is 1 point. So there's one solution to the system, and it is the point 0, negative 1. Now, it's not always that easy to tell the solution of a system by graphing. So we can use algebra, substitution, and elimination. So let's solve this one by substitution. So let's solve each of these equations for y. So on the top, we'll add the y over to the right side and then add the 1 to the left. So y equals x squared plus x plus 1. In our second equation, let's subtract our x value. So y equals negative x plus 4. Now to substitute, we'll take the value for y value in the second equation and substitute it into the y value of the first equation. So we have negative x plus 4 equals x squared plus x plus 1. Let's move everything over to the right side of the equation. So 0 equals x squared plus 2x minus 3. Now let's first see if we can factor, and I believe we can, because two numbers that will multiply to give us negative 3 and add to give us 2 are 3 and negative 1. So we have the expressions x minus 3 times x minus 1. Let's set those both equal to 0 and find the x values of our 2 points of intersection. So our x values are at negative 3 and 1. So let's start by finding the y value that goes with negative 3. So we can plug it into either one of the original equations, and I'm plugging it into the linear equation. So y equals the negative of negative 3 plus 4, which gives us 3 plus 4, or 7. So that is our first point of intersection. And now let's find our second point of intersection. So we plug in 1 for x, and we get negative 1 plus 4, or 3. So this system has 2 points of intersections, 2 solutions, 2 real solutions. Now let's solve this nonlinear system by elimination, although I think I solved it by substitution. I did. So there's another example coming up that I do solve by elimination. So by substitution, I'm going to solve both of these equations for y. So the top one, I move the y over to the right and the negative 2 to the left. And then in the second one, I subtract my x squared and my negative 2x. And now I will plug that in to the top equation. So we'll get negative x squared minus 2x equals 2x squared minus 5x plus 2. I'm going to move everything over to the right side of the equation. And I have 3x squared minus 3x plus 2 to solve. Now I take a minute just to see if this will factor. So two numbers that I'll multiply to give me 6 and combine to give me 3. And I know that's not possible. So I'm going to use the quadratic formula. You can always use that to solve a quadratic. So I'm going to take the opposite of b, plus or minus the square root of negative 3 squared minus 4 times 3 times 2. So we'll start with evaluating what's underneath our square root, which is negative 15. So that means we're going to have 2 imaginary solutions. 3 plus or minus I times the square root of 15 all over 6. So since we're looking for real solutions, we say that this system has no real solution since we ended up with 2 imaginary. Now on this one I solve using substitution as well. So I solve for y and then in both of my equations. So you can see I subtracted my x squared and my 3x over in this first equation and subtracted my 2x in the second one. So now I'll take the value for y in the second and substitute it into the first. So we'll move everything over to the left side. I just like to keep the x squared positive if possible. And then I see if I can factor that. So two numbers that I'll multiply to give me 5, and if I add, I get 1, and that is not possible. So I'm going to use the quadratic formula. I pick out a, b, and c, and then I plug in my values. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 5 all over 2. So negative 1 plus or minus negative 19. So again, I'm going to have 2 imaginary solutions. So this system has no real solutions. Now, in the next example, I am going to solve using elimination. So I solve each of these for y, and then I realize if I subtract that I can eliminate my y's. So I subtract each of these pairs of terms, and I get positive 3x squared plus 4x, and then my 2 minus 2 will become 0. So now to solve this, I can factor out my greatest common factor of x. I'm left with 3x plus 4, and I can set each of those factors equal to 0 and solve. So my first x value is 0, and my second one is negative 4/3. So I'm going to end up with 2 real solutions. We need to find the y values that go with these. So I'm going to plug in 0 and into my second equation, and I get positive 2. And now I'm going to plug in negative 4/3 into my second equation. And so I square my 4/3, which gives me 16/9, add 2, or 18/9. Or sorry, that gives me negative 16/9 plus 18/9, which will be 2/9. So we end up with 2 real solutions. Now, sometimes we can have nonlinear systems with circles. And so a circle has an equation in the form x squared plus y squared equals r squared. This is a circle of an equation in standard form. The center is 0, 0, and the radius is r. When the graphs of the equations in a system are aligned in a circle, the graphs can intersect in 0, 1, or 2 points. And so if they intersect in 0 points, they have no solution. If they intersect in 1, they have 1 solution, and intersect in 2, they have 2 solutions. So let's solve this system by substitution. We're going to take what y equals from the second equation and plug it into our first equation. So we get x squared plus the quantity negative 3x plus 10 squared equals 10. Now over to the right, I am going to square negative 3x plus 10. So I'm going to FOIL that. First terms together will give me positive 9x squared. Outer terms is negative 30x. Inner terms is also negative 30x. My last term is 100. So now, putting it in my equation and combining like terms, I get 9x squared minus 60x plus 100 equals 10. And then cleaning up that equation, we get 10x squared minus 60x, and I subtract my 10 over plus 90 equals 0. Now before I solve, I notice I have a common factor of 10, so I'm going to divide away that common factor. And that gives me a more manageable quadratic to solve. I notice that this does factor because the two numbers that will multiply to give me 9 and add to give me negative 6 are negative 3 and negative 3, or negative 3, x minus 3 squared. So solving, we end up with one x solution, x equals 3. So this nonlinear system intersects in 1 point. So let's plug in our x value into our second equation in the system, and we get the point 3, 1. Now we want to check to make sure that we have a correct solution. So I plug the point 3, 1 into each equation for x and y. In my first equation, I get 3 squared plus 1 squared equals 10, and that's true because 3 squared is 9 and 1 squared is 1, and that equals 10. And on the left side, I get 1 equals negative 9 plus 10, or 1 equals 1. Now let's look at a couple more nonlinear systems with circles. So again, we're going to plug in the value of y from our second equation into our first. And when I square that, that should be y squared here. I end up with x squared plus x squared minus 8x plus 16 equals 16. Cleaning that up, 2x squared minus 8 equals 0, moving everything over to the left side. I can start by factoring out the common factor of 2x, and then setting each of those equal to 0. So my two x solutions will be x equals 0 and 4. And then I need to find the y values that go with those, so I plug them into my second equation. So I get the point 0, 4 and 4, 0. And now taking for c, we're going to take the value of y in the second one and plug it in for y in the first equation. We end up getting x squared plus 8x plus 16 equals 4. And then combining like terms, 2x squared plus 8x plus 12. Now before we solve, I notice I can divide all of those by 2. It has the greatest common factor. And that leaves me with x squared plus 4x plus 6 to solve. That will not factor for me, so I am going to use the quadratic formula. And I end up with negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 6, which is negative 8. Now notice I can simplify those. So I can divide my 4, my 2i, and my 2 all by 2. So I'm going to do that, and I'm going to erase what I have and then replace. So I end up with negative 2, should be a negative there, plus or minus 2i all over 1. Don't need to write that. So I have no real solutions.